One server crashes under a million users. Here's what survives instead. I'm Kai, and system design is the answer. How you split one fragile machine into pieces that don't all fail together. It's not about writing clever code, it's about how those pieces talk to each other. Every big engineering interview touches this, and every real outage traces back to skipping one of these ideas. Let's build the whole picture, one small piece at a time. Two words carry this entire video, so let's nail them fast. Latency is how long one coffee takes to reach your table. Throughput is how many coffees the whole cafe serves per minute. A slow cafe with one waiter has bad latency, a busy cafe with one waiter has bad throughput, and fixing each one takes a different trick. Keep those two words in your head, everything from here on is just ways to improve them. Imagine your one cafe is overwhelmed with customers. You could hire a giant super barista who works twice as fast, that is vertical scaling, one bigger machine. Or you could open three normal cafes next door, that is horizontal scaling, many normal machines sharing the work. Horizontal wins for big systems because if one cafe burns down, the other two are still serving coffee. In short, most small machines beat one giant machine when failure is a real risk. Now that we have many servers, someone has to decide which server handles which request. That is the load balancer. Think of it as the host at a restaurant entrance pointing each customer to an open table. If one table, meaning one server, stops responding, the host quietly stops sending people there. In short, a load balancer spreads work around and hides failures from the customer. Here's the trick with caching. If a customer keeps asking the same question, you write the answer on a sticky note instead of looking it up every single time. In code, we check the cache first and only hit the slow database if the sticky note is missing. This can turn a request that takes 200 milliseconds into one that takes 2 milliseconds. In short, caching trades a little memory for a lot of speed. Databases get hammered with far more reads than writes in most apps, so we make copies called replicas. Think of it like a teacher writing notes on the main whiteboard, while students photograph copies to read from at their own desks. Only the teacher, our primary database, is allowed to write, but everyone can read from the copies. In short, one source of truth for writing, many copies for fast reading. Sometimes even a fast database is just too full. One machine cannot physically store all the rows. So we shard, meaning we split the data by some rule, like putting users A through M on one machine and N through Z on another. Each shard is smaller and faster, but now your application needs to know which shard to ask. In short, sharding is dividing a huge table into smaller manageable pieces. Picture dropping your dry cleaning off at the counter. You do not stand there watching them clean it, you just leave with the ticket and come back later. A message queue works the same way. Your app drops a task like sending an email into the queue and immediately moves on. A separate worker picks it up whenever it is free and does the slow part. In short, queues let fast and slow work happen without anyone waiting around. Here's a mistake I actually made early in my career. I built a system with one database and told myself I would add a backup later. Later never came, and one night that single server crashed and the entire product went dark for hours. A single point of failure is any one piece that, if it dies, takes the whole system with it. In short, always ask yourself what happens if this one thing disappears right now. The other classic trap is caching something and then forgetting to ever refresh it, so users see prices or statuses that are just plain wrong. You might wonder why this happens so often. It is because caching feels done once it works, but stale data quietly rots underneath. The fix is to set an expiry time or explicitly clear the cache whenever the real data changes. In short, a cache without an expiry plan is a bug waiting to happen. SQL databases are like a strict filing cabinet. Every folder has the same fixed structure and rules, which makes your data very reliable. NoSQL databases are more like a big flexible box. You can toss in different shaped items, and it scales out across many machines more easily. My honest opinion here is that people jump to NoSQL for scale. They will never actually reach, when a well-indexed SQL database would have been simpler and safer. In short, choose structure and safety with SQL, choose flexibility and scale with NoSQL based on what you truly need. A monolith is one big application where everything lives together, simple to build and deploy, like one restaurant kitchen making everything. Microservices split that kitchen into separate stations for orders, payments, and shipping, each one independently built and scaled. But now those stations have to talk over a network, which adds delay and new ways to fail. In short, monoliths are simpler to start. Microservices are better only once you truly have separate teams and separate scaling needs. So here is the trick. None of these pieces work alone. They stack together into one system. Traffic hits the load balancer, gets spread to servers. Those servers check the cache first, fall back to the database with its replicas and shards, and push slow work onto a queue. Watching all these pieces click into place is genuinely satisfying once you have built one yourself. Keen? Here's the one question that replaces memorizing 6 terms. What happens to this system if this one page disappears right now? Ask that about your server, your cache, your database, your queue, and you basically design the whole thing. That's the real skill, not the vocabulary, the instinct to hunt for the next single point of failure. If this mental map helped, one follow actually moves the needle on a channel this small.